Hi Algebra students, welcome to video 5. In this video we're learning our final form of quadratic equations, which is factored form. We're also reviewing how to factor using the greatest common factor method. So here's our new form, factored form. It looks like this: y equals a times x minus p times x minus q. And just like in all our other forms, these letters mean something. What's nice about the a value in all three forms is it always means the same thing. So same thing as it meant in vertex form. If it's a negative a value, we flip our parabola to be upside down. If the a value is if the a value is greater than 1, we have a stretch, which means we have a narrower parabola. And if our a value is less than 1, we have a compression, which means we have a wider parabola. And now what these p and q values are the x-intercepts. So factored form gives us x-intercepts. So p is an x-intercept. And we'll just say it's x-intercept number 1. So that x-intercept would be the value p. And then the other x-intercept would be q. X-intercept number 2 is q. Okay, so what that means on our graphs is if I give you this equation and we're trying to graph it, well, we have x minus 4 and x minus 2. We should be able to look at this and find our x-intercepts. So we have two x-intercepts. One of them would be 4, and one of them would be 2. It's the opposite sign of the number with the x. So x-intercepts of 4 and 2. Well, all right, that's all we're supposed to know from that. But what we know about parabolas is that they're symmetric. So if we have x-intercepts on 2 and 4, we know that the vertex needs to be right in the middle of them. So right in the middle of 2 and 4 is 3. We know that that needs to be our axis of symmetry. So that's something we know. Axis of symmetry is the equation x equals 3. So then where do we put our vertex? Well, we know how to find the vertex. We can plug in 3 to our equation and see what we get for y. All right, so plugging in 3 to this equation, we get y equals 3 minus 4 times 3 minus 2. All right, order of operations says you have to do parentheses first. So 3 minus 4 is negative 1. 3 minus 2 is 1. Multiplying that, you get negative 1. All right, so our vertex is the point 3, negative 1. And there we have it, our parabola. The a value was positive, which tells us it should have opened up, and it did. Okay. This next one, number 2, it doesn't exactly look like it's in factored form, but this very first x, it's just a plain old x, so we could write it as x plus 0 if we wanted to make it look more like factored form. So that means our x-intercepts are 0 and the opposite sign of the number with the x, so negative 2. So that means x-intercepts of 0 and negative 2. Right in the middle of 0 and negative 2 is negative 1. So that's our axis of symmetry, and that's the x-coordinate of our vertex, negative 1 comma something. We need to figure out what to put there for the y value. So we plug that into our equation, y equals negative, and then we put a negative 1 for x times negative 1 plus 2. Order of operations first says we need to do negative 1 plus 2, which is 1. So negative times negative 1 times 1 is 1. Our vertex is at the point negative 1, 1. It looks like this parabola wants to open down. Let's check to make sure that makes sense. Yep, we have a negative a value. It was supposed to open down. Perfect. Okay, if you want to try a couple on your own, it would be a good idea to pause the video now and try these two. Otherwise, I'll be going through them now. So we have two x-intercepts here. One is the opposite sign of this first x value. So 7, and the other one is 3. 7 and 3. Right in the middle of 7 and 3 is 5. So for our vertex, we have 5 comma something. We need to plug 5 in to find the y value. So we get y equals 5 minus 7 times 5 minus 3. 5 minus 7 is negative 2. 5 minus 3 is 2. When we multiply those together, we get negative 4. So our vertex is 5, negative 4. Connecting our 3 points, we get a parabola that opens up, which it was supposed to because we had a positive y value, or a value, I mean. All right, the last example, our x-intercepts are the opposite of the numbers with the x in the parentheses, so x equals 5 and x equals 1. There we go. In the middle of 5 and 1 is 3, so our vertex is 3 comma something. Plugging that into our function, we need to find our y value. So y equals negative 3 minus 5 times 3 minus 1. Okay, 3 minus 5 is negative 2. 3 minus 1 is 2. Multiplying that all out, we get 4. So our vertex is the point 3 comma 4. This looks like it was supposed to open down, and if you check our a value, yep, we have a negative a value, which tells us our parabola should open down. So that's what graphing in factored form looks like. What your homework is going to look like is I will be giving you the graphs, and you need to match it to the equation. So what you need to do is you need to look for your x-intercepts. Here we have x equals 0 and x equals 5 for our x-intercepts. Well, that means we should have x minus 0 and x minus 5 in our factored form. There's really no reason why you would need to write x minus 0, because subtracting 0 doesn't really do much. So you could just write it as x times x minus 5. Well, the only option that looks even close to that is a. So there's our factored form for number 5. Okay, number 6, we have an x-intercept of 3 and an x-intercept of 6. That means our factored form should be x minus 3 and x minus 6, with maybe an a value out front. All right, x minus 6, x minus 3, that looks pretty good. It looks like we have a pretty wide parabola, so that negative 1/4 makes sense because it got compressed. And it's opening downwards, so we do have a negative a value. So there we go, option D. Okay, the next problem, feel free to pause the video and try the next two. In number 7, we have x-intercepts of negative 6 and 2. So in factored form, that would be x plus 6 and x minus 2. And maybe an a value out front. So looking through these options, well, there's only one option that looks even close. And it does have a positive a value, which we need. It opens up, so option B it is. All right, and our final one, this one is unique because, look, we only have one x-intercept, so we only have x equals 4, which in factored form is x minus 4. But this is a quadratic, and we need it to have an x squared, so even though it's only one x-intercept, we say it's squared. We don't quite exactly know what the a value might be, but we do know it opens down, so we do know it needs a negative a value. Looking at your options, x minus 4 with a negative a value, the best choice there is a. So this is kind of what your homework looks like. The last part of your homework is factoring using the greatest common factor. This is a review. So these are factoring problems that look kind of like this, where what you need to ask yourself is, looking at this first problem, is there something that both of these, or that you can divide both of these terms by? And to me it looks like I can divide them both by 7. So I'm going to put 7 outside of the parentheses, and then you have to think to yourself, if you were going to FOIL this, or distribute the 7 inside the parentheses, what would have had to be there for you to get 7x? Well, 7 times x is 7x. 7 times what would have given us negative 28? Negative 4. So the factored form is 7 times x minus 4. Okay, in this next problem, I see that I can divide both numbers by 2 and that they both also share an x. So I'm going to factor out 2x. 2x times x gives you 2x squared, and 2x times negative 5 gives you negative 10x. So here's our factored form. And the last problem, the number that you can divide both 30 and 9 by is 3. So 3 times 10x is 30x, and 3 times 3 is 9. So there's the factored form using the greatest common factor. You are now ready to go do homework 5 on Delta Math. Good luck.